Hello viewers, welcome to my YouTube channel. Is the Science Demystifier. In today's video, I will be taking you through the process of naming the unsaturated hydrocarbon family. The unsaturated hydrocarbon family consists of the family of the alkenes and the alkynes. Okay, so this is a series I started a few weeks ago. I'd already posted video on the nomenclature, how to give the nomenclature of the alkanes, and the alkanes are the saturated hydrocarbons. Okay, so we're going to learn how to name the alkenes and the alkynes. Now I want you to follow me as I run through this process, as I run through this series, because I'm going to not just stopping at the hydrocarbons, but I will also extend it to the nomenclature of other homologous series like the family of the alkanoic acids, the alkanals, the alkanones, the esters, that's the alkanoids, the amines, the amides. So, without wasting much of your time, let's go to class and demystify the process. Okay, now before we go into the IUPAC nomenclature of the unsaturated hydrocarbons, I think it's very important to look at the rules that guides the IUPAC system of naming the unsaturated hydrocarbons, that is the alkenes and the alkynes. Now, the first rule is that the parent chain is the chain that bears the root name of the compound. The parent chain of the compound will be the longest continuous chain. Remember the word continuous. So in this compound now, use this compound to give an example of what is meant by longest continuous chain. So look at this compound now. This CH, this side chain, this is a side chain. And this is the longest continuous chain. I've already cycled it. So in alkenes, we don't add branched or side chains to the principal chain. Why? Because the compound has a double bond. Double bonds in compounds, organic compounds, do not allow free rotation of the compound. So the longest possible chain is taken to be this straight continuous chain here. Okay, that's rule number one. Rule number two says numbering of an alkene or an alkyne is done starting with the end that is closer to where you have the double or triple bond. So when you want to number your chain, which is very, very important in naming organic compounds, numbering is always done to give position to any substituent group that might be in the compound, or to locate or to show the position of the double bond or double bonds in the chain. Okay, now let's look at this compound now. You can see here we have this end, and then we have this other end. And then here is the position of the double bond. If I should start from here, if I count from here, 1, 2, 3, I have 3 carbon atoms before where I have the double bond. And if I should start from here, I have 1, 2, 3, 4. So I have 4 carbon atoms before where I have the double bond. So obviously, starting from here will give us a lower count, to where we have the double bond. So numbering should start from this end. So that's what rule number 2 is saying. Start your numbering from the end that is closer to where you have your double or triple bond. Now let us look at rule number 3. Rule number 3. Okay, now rule number 3 is how to give the root name of the compound after numbering your principal chain. How to give the root name of the compound. Now, the root name is obtained simply by counting the number of carbon atoms on the longest continuous chain. Like in this case, we have 1, 2, 3, 4. And that goes with the word but. This is but. Okay, so the but, you put a hyphen, then the number inserted here is called a locant. That's what it's called. It's called a locant. It gives the position of the carbon atom before the double bond. The carbon atom before the double bond. Now, assuming I'm starting my numbering from here, this is carbon number 1, is carbon number 2. So the 2 is the locant of this carbon atom. So this shows that this carbon atom is in position number 2. So that's why we inserted 2 here in the name. So it will be but 2. Then the last word they're going to use here will be the suffix. So this is an alkene member. Why? Because of the double bond. And that's why the name ended with in, E-N-A. That's brought 2 in. Now let us go to rule number 3. Rule number 3 is when you have more than one double bond or triple bond in the same principal chain. When you have more than one double bond or triple bond in the same principal chain. When that happens, we use the word diene in the suffix or as the suffix. We use diene when you have two double bond. For example, look at this compound. So this compound is a diene. So this is a diene. Why? Because it has what? It has a double bond. It has a double bond. That's why it's called a diene. So to give the root name of a diene, what we simply do is to assign numbers, that's numbering of the chain. Remember the rules or the rule given to you for numbering. You start from the end that's closer to where you have the double bond. So obviously, I'm going to start from this side. So this is carbon number 1. This is carbon number 2, carbon number 3, number 4. So you can see now that carbon number 1 comes before where you have the first double bond, and then carbon number 2 comes before where you have the second double bond. And then the root name is but, because we have 4 carbon atoms, so it goes like this. But you put the numbers which are the locants of the 2 carbon atoms. The locant of this carbon atom is 1. The locant of this carbon atom is 2. So 1, 2, sorry, I think I should have a comma here. 1, 2, then now put diene. The di here means you have 2 carbon atoms in the compound. So that's how to handle compounds with more than one double bond. The same thing applies to the alkynes. If you have 2 triple bonds in a chain, it becomes a diene. As that D-I-Y-N-E, diene. So following the same rule, you have to pick the locants of the carbon atoms before where you have the double bond. So now let us go to rule number 4. Okay, now let's look at rule number 4. Now rule number 4 is set to address cases like this, where you have a triple bond and a double bond on the same chain. So how do you name compounds like this? You start first by numbering the chain. And in numbering, preference is given to where you have the triple bond, not where you have the double bond. So you consider the end that is closer to where you have the triple bond, not the double bond. So here is obviously the end that is closer to where we have the triple bond. So that is why I started my numbering from this end, as you can see. So I've numbered the chain. Now the next step is for you to give the root name of the compound by counting the number of carbon atoms we have on the chain. So we have 1, 2, 3, 4, 5, and that is pents. That's why we have pent here. Then insert the locant before the suffixes. For the first suffix, which is the in, remember when you want to give the name, the in will come before the ein. So I'm starting with the in. Now the locant before the in is 5. So that's why I inserted 5 in. But when you want to write the in, you don't put the terminal e. The terminal e is removed and is replaced with en. Okay, that is the rule. You remove the e, and then, but the ein is written in full. That's Y-N-A. So the locant for the in is 5. The locant for the ein is 3. That is this carbon atom before where you have a triple bond. So the name goes as thus: pent 5 and 3 iron, pent 5 and 3 iron. So now let's go to rule number 5. Okay, now let's look at rule number 5. Rule number 5 applies to prefixes in unsaturated compounds. As you can see in this case, there is a substituent group, the chloro group, and the methyl group. So when you have them attached to the principal chain, how do you go about it? The same, just like the same thing I taught you in the nomenclature of alkanes. So the same rule applies. So we have the numbering starting from here. This carbon number 1, this carbon number 2, 3, 4, 5. So the chloro group and the methyl group, they are in the same position, number 4. So the name goes as thus. We have 4 chloro, 4 methyl, pent, 1 in. 4 chloro, 4 methyl, pent, 1 in. Now lastly, let's go to rule number 6, and that applies to the trans and the cis isomers. So for the trans and the cis isomers, you see something like this. When you have substituent groups, positioned like this, that is facing the same direction across the double bond. You can see here they're facing different directions across the double bond. So when you have situations like this, how do you go about the nomenclature? So you begin the name of the compound with cis when the substituent groups are facing the same direction, and then you start the name with trans if they are facing different directions. So we are bringing today's class to a close. In my next video, I'll be taking you through the process of naming the alkanoic acids and the alkanols, including the alkanoids, that is the esters, the family of the esters. And when we are done with these series or these families, we will now look at the family of the alkanals and the alkanones. And when we are done with the family of the alkanals and the alkanones, I will also make a video on the nomenclature of the amines and the amides. Okay? So I just want you to follow me as I run through this series. If you are a returning subscriber, thank you so much for being there. Thank you for your support. There wouldn't be this channel without you. Okay? I really appreciate you. Please do well to share this video to people that need it, mostly students in first year in the university and also students in the secondary school, senior secondary, precisely. Okay? All right. So if you are a new subscriber or an intended subscriber, or this is the first time you are watching me here live on this channel, please be kind enough to hit the subscribe button. Right below there, it's right below there. Don't say you did not see it. It's right below there. So just hit the subscribe button. That's the only way you can encourage the Science Demystifiers channel to grow. Okay? So with the subscription, you encourage us to do more, to bring more to the table. Okay? So see you in my next video when I will be taking you through the nomenclature of the alkanoic acids, the alkanols, and the alkanoids. Thanks for watching.